Hey guys, welcome back to our channel. Today we are going to solve a problem known as the subarray with the given XOR. Okay, so in this problem, what we have to do is we are given an array of integers and we have to find the count of all the subarrays such that the XOR of all elements in that subarray equals to an integer b. Okay, that is the problem statement. Okay, so before we start coding this, let's think of all the possible solutions and what exactly we meant by the XOR operations and what we have to, return. Okay, let's start. So we are given an array 4, 2, 2, 6, 4, and we have to count all the subarrays of which all the elements, if we XOR them, we get a result as B. And here the value of B is 6. Okay. So now let's start. Before we start, okay, we should know, right, what is a XOR. Okay, so two things to keep in mind about XOR operation is any number, let's say n, XOR with 0 will give you the same number back. Okay, and any number XOR with itself will give you 0. Okay, these two are the things you have to keep in mind when you are doing a XOR operation. Okay, these two are the basic things. Okay, so just remember this. Okay, keep this in mind. Okay, now, so let's say what we have to do now is we have to find all the subarrays which having a XOR is same. Okay, so before we start, the most obvious solution can be check generate all the subarrays and check the XOR of all the elements in that subarray, and if it is equal to 6, increase your count, right? So we have now we have discussed this multiple times how to generate subarrays, right? It is basic, right? Like, so what is a subarray? Let's say I'm at this first index, right? This 4 2 is a subarray, 4 2 2 is a subarray, 4 2 2 6 is a subarray, and so on, right? Similarly, 2 2 is a subarray, 2 2 6 is a subarray, 2 2 4. So basically, we are taking each number and then making a subarray with the all the other elements of the array, right? So let's see from an example, right? So what we can do is, let's say we can run a loop I is equal to 0, I less than, let's say n is the length of the array, and I plus plus, right? Now what we can do is for every I that we are using, that is I plus 1, right? We can generate all the subarrays, right? Now what we can do is, let's say here we have a variable called as XOR, right? And we can XOR whatever coming with us. Okay, and if by any chance this XOR turns down to be RB, that means we can take a counter variable here in the beginning and increase our counter. Okay, so whenever we are XORing each element, generating all the subarrays and the XOR, and if any chance this XOR is equals to B, that is our question requirement, we can simply increase our counter, and once we are done, we can just return our counter, right? So this is the most basic approach, right? We are doing nothing, just generating all the subarrays, XORing them, and if the XOR is equal to the B, which is the resultant XOR, we are increasing our counter and return the counter, right? So talking about the space and time complexity, what we have done is we are iterating using two loops and iterating for each element. We are iterating whole array. So n square will be my time complexity, assuming n is the length of the array. We are using constant space for this counter, that is just nothing. So the space. So now we have understood the brute force approach in which we generated all the subarrays and find the XOR, and whenever the XOR is equivalent to RB, we are increasing our counter, right? So what we are done in earlier approach is, let's say we started from 4, then we did XOR of 2, then again we did XOR, and so on, right? We are XORing in one element, each element one by one in the forward direction, right? So that's why we need two for loops to generate subarrays and XORing them, right? Now, as we did in forward direction, taking each element one by one, now let's think something different, right? What about thinking or taking elements in backward direction? Okay. And what I meant by this backward direction is, okay, understand this with an example. Okay. Let's say I have the same array. Okay. I'm just taking the same array 42264. Okay. So in this example, assume, let's say, okay, I did XOR from 0 to 6. Okay. I am at my current element 6. Okay. That is 0, 1, 2, 3. Okay. I am at my index 3 and till 6, let's say the XOR is equivalent to P, right? Now, I assume that till 6, I have found subarrays which has XOR B, right? So, if I say this line or this statement, it means that before 6, there must be a subarray, let's say this, assume, okay, which has a XOR B, correct? Now, what is left? This area, let's say the remaining area has XOR X, right? So I can say X XOR B, right? Like two halves, the XOR of two halves must be equivalent to the total XOR, that is still 6, which is P, correct? Now, if I am till 6, I know the XOR, and if I want the subarray with XOR B should exist, right? That means I need to find X, right? And if X exists between this 4 to 6, that means I have found my B, correct? X should exist. Now, what is the value of X? XORing both sides, okay, with B. So it will be same. Now we are XORing the same element, and if we XOR same, that means 0. So X XOR 0 is equal to P XOR B, and any number XOR with 0 is X. So X will give us P XOR B, right? So that means if till 6, if we have found an array or subarray with XOR X, that means we have found our B. That's what it is. So that means we need to search this X if it has occurred or not, right? And whenever we need to search if it has occurred or not, any occurrences or anything like that happened in the past, that means we need to do the hashing, right? Correct? We will store that. Okay. Now, so before we start, let's keep this equation in mind, that what we have to do. Like we know the value of X will be like this, right? Now, let's start our iteration, okay, and see this approach in action, okay. Now, I have my hash table here, and let us initialize it with 0 and 1, okay. Like this 0 is my XOR, the current XOR, and 1 is my count, like how many times this XOR has occurred, okay. And initializing it with 0, you will understand this, once we start iteration, okay. Now, what we need to do? We need to start iteration, okay. Let's say this is my P, okay, and this is my X, and let's start, okay. My current element is 4, correct? Now, this is 4, right? So my P will be 4 because I initialize it with 0, so my P is 4, right? Now, what is X? X will be 4 XOR B, right? And if I say it to be precise, that means B is 6, right? What is the value of 4 XOR 6? Let's find out. Okay, let me show you how to find the XOR if you people don't know. Okay, we just need to write in the bits. What is a 4 in bits? It will be 0, 0, 1, and 6 will be 1, 1, 0. So 0 0 0, that means same number, it will be 0, 0 0 1, it will be 1, 1 1 0, right? So 0 1 0 in decimal, it will be equivalent to 2. So my P XOR B is equal to 2, that is this X, right? Correct. Now what we need to do? Search, does this exist or not, like, right? And 2 doesn't exist, right? As this is equivalent to 2. 2 exists? No. What we will do? We will store this P. That means 4 and its occurrence is 1, right? Now, moving to the next element, that is 2, correct? Now, what is P? P will be 4 XOR 2, because still here is 4 and now the next element is 2, right? Now, let's evaluate this. What is 4 XOR 2? Okay. 4, how to write 4? 0 0 1, and 2 will be 0 1 0. So 0 0 will give us 0, 1 0 1, and 1 0 1. That means 6, right? So does 6, we got the, like, is equivalent to 6, right? Now what is X? 6 XOR 6, because P is 6. So 6 XOR 6, that is same number, that is 0, right? So does 0 exist? Yes, it does. So what we will do is, we will, like, make our count as 1, because till now we have got the count as 1, right? Now, moving to the next element, and before we move, what we need to do is, we need to store the current XOR till 2, which is 6, and its occurrence is 1, right? Now, moving to the next element, that is my P will be 6 XOR 2, right? And what it will be? 4. Okay, I'm not calculating, you people can calculate now. Okay, 6 XOR 2 is 4, right? Now P XOR B is X, so 4 XOR 6, it will be 2. Does 2 exist? No. That means we haven't found the 2. What we will do is, we will store the 4, and 4, as 4 already exists, so we'll increase its count by 1, that is 2, right? Now, moving to the next element, that is 6. So our current P will be previous till here 4, that is 6, which is equivalent to 2. Now 2 XOR 6 is equivalent to 4. Okay. So does 4 exist? Yes, it does. And it has a count 2. What we will do is, we will increase our count by 2. It will be 3. Right? And it will be 3. And so what we will do is, we will store the value of 2. That is 1. Okay. Now, moving to the next element. That is 4. So P will be 2 XOR 4, which is 6. And 6 XOR 6 is 0. Does 0 exist? Yes, it does. And it has a count as 1. So what we will do? We will increase our counter by 1. Okay. Now iteration is done. And the total count of subarrays with XOR as B, which is 6, is 4. Okay. So that's how is the dry run. Now talking about the space and time complexity. What we have done is, we have done only one iteration. So the time complexity will be of n is the length of the array. And we used extra space in terms of hashing. So the space complexity will be of n. Okay. Now let's start thinking if there is any better approach, or maybe start coding this up. So hopefully you would have understood the brute force and the optimal approach. So let's get back to our code editor and start coding this up. So now we are back to our code editor, and let's start solving this problem. Okay. So what we are given? We are given an array of integers, that is a, and we are given a B, that is the XOR which we are going to find of the subarray, and we have to return the count of the subarrays which having a XOR B. Okay, so that means let's initialize our count of subarrays, and in the end we know we will return this count, right? Now what more we need to do? We need to find our P, right, which I have told, that is the current XOR, and let's initialize it with 0. Okay, and in initializing our hash object, in which we are initializing a XOR 0 and it has a count 1. Okay, now what we will do is we will loop through our array, that is a dot length, right? And after that, what we need to do? We need to first do the XOR, right? We will calculate the current XOR, which is P, and for the first element, P XOR A of I, right? And then we will search, right? Element to be searched, right? It will be, we know, P XOR B, right? If element, or we can say, if my hash objects contains this element to be searched, that means it will be not equal to undefined. And if it is that, that means I can increase my counter to whatever is stored in my hash table, right? After that, what else can be possible? We need to check if this P, that is my current XOR, is there in our hash table or not, right? If it is there, that means we need to increase the value of P. That means we have found one more count, we will increase the count by 1. Otherwise, it is not, that means this P doesn't exist in my hash table, so I will initialize it with 1, right? That's what we need to do. Let's try to run this code. So it is compiled successfully, and let's submit this up. Okay, now it is submitting, and let's see. Yeah, so we have answered it correctly. So that's it for this video, and if you guys have any doubts, then feel free to mention in the comments. I will help you out, and if you have understood, just mention understood. So we will see you in the next one. Till then, take care. Bye bye.